Hey, y'all, let's cover section 5.1, and this is going to be over quadratics or parabolas, is the other known name for them. So recognizing the characteristics of a parabola. The parabola is going to either open up, concave up, or it's going to open down, concave down. All right. In that case, it would be a reflection, but we've already talked about that before. So let's talk about the different pieces of a parabola. One is the vertex. That's either going to be the lowest point or the highest point. And the vertex is always represented in an XY format because it's a point on an Cartesian coordinate system. And the point is always referenced as HK. Okay, that vertex is always referenced as HK. The next thing you need to understand, which you already know, is y-intercept is where that parabola crosses the y-axis, okay, or f of x axis. Remember, y and f of x is the same thing. The next thing is the x-intercepts. Well, in a lot of cases, you will not hear me or my open math reference x-intercepts. Instead, you'll hear us reference zeros. I suppose zeros. It might have an E, I don't remember. Oh, here it is, right here. It does not have an E. Sorry, y'all. Zeros. So the x-intercepts are your zeros. Just make sure that you understand that that's the case, because if I ask you for the zeros of the quadratic, then I'm expecting you to tell me what the x-intercepts are. You need to know the vocabulary. The last piece here is the axis of symmetry. The axis of symmetry is a line. It's a faux line. It's where the parabola is split in half, and it is always referenced as the equation x equals, and it's always whatever the h is in your vertex. So it's x equals h. All right. And you would write it in this format. You wouldn't just write h. You would give me an equation, x equals h. All right. Determine the vertex, axis of symmetry, zeros, and y-intercept of the parabola. So the vertex is right here. It's the lowest point, and it is 3, 1. So the vertex is HK, and in this case, it is 3, 1. I can do the axis of symmetry too while I'm at it, because axis of symmetry is just x equals whatever the h value is, 3. And that is being referenced by this imaginary line here. All right, that is x equals 3. Next is the zeros. Well, the zeros, there are none because it does not touch the x-axis at all. So no zeros. And then the y-intercept is right here, and that is at 0, 7. 0, 7. That is a point. All right. I think that's it for that one. Two different things here. Well, a couple. One is sometimes you will be asked to reference the general form of the quadratic function, so general form for a parabola, and that's just the functions equal to ax squared plus bx plus c. You're going to have to be able to take this and transform it to a standard form for a quadratic, which there's another term for this as well. Standard form is also known as the vertex form, because it easily shows us what the vertex is because there's h and k referenced. All right. Also notice, if you remember, we had to solve for a in the previous module. In this case, I gave you how to find a really easy, because you don't have to actually solve for it. It's going to be given in your original general form of your quadratic as the coefficient of x squared. All right, to find your vertex, if you're given this form and you need to find your vertex, all you need to do is, one, you can complete the square. That's one way we'll do it. The other way is to take, you've got a, b, and c here, and h is equal to negative b divided by 2 times the coefficient of x squared, which is a. Once you have that, you can plug h into where the x is and solve for k by doing it this way. Okay, we'll do that. You can read the how-to if you'd like to. I'm going to come down here And let's just find this in the vertex form. I don't think I did this in the class, but I want to do it here. So we do have a vertex. We have x-intercepts, we have axis of symmetry. Let's just find out what all of these things are. So our vertex is HK. H is 2, -2. Yep, and then down 1, so -1. All right, our axis of symmetry is x equals, it's always x equals, and in this case it is -2, which is your H value as well. X-intercepts or zeros are 1, -1, 0, and -3, 0. Okay, y-intercept is 0, 3. Let's just find everything here. Is 0, 3. All right, that's all the things from the last page. Let's go through here and write. They've got the general, this is the general form up here, the general form of the quadratic. That's what this is. Let's take this and find our vertex just using this, just to have you have another example for this. So we've got y equals x squared plus 4x plus 3. Well, h, which is the x value for your vertex, is equal to -b over 2 times a. So we need to know what a is and what b is for this. A equals and b equals. If there's no number out on in the front of your x squared, the coefficient, then that has to be a 1. It can't be a 0, because if it was a 0, there wouldn't be an x squared. So that's a 1. And then your b is 4. It's the coefficient of your x. So negative, and then what is b? 4 divided by 2 times a, -4 over 2, which is -2. So which came out to our perfect. Let's just, the other way to show you how to solve for k is taking the function itself, and instead of x, you're going to put in h. It's an h, and our h is -2. So -2 squared plus 4 times -2 plus 3, 4 minus 8 plus 3, that's -4 plus 3 is -1, which came out correctly. Awesome. One more thing is to take this and put it into the vertex form or a standard form. So that would be f of x is equal to a x minus h squared plus k. A, we already know is 1 because that's the coefficient of x squared, so I don't need to worry about that. And then x minus, what is our h? -2 squared, and then k is -1. Clean this up. Please don't leave it like this. And then that is what your vertex or standard form looks like. Let me know what questions y'all have as we do this. Write an equation for the quadratic function g as a transformation of the quadratic. Then expand to write in general form. In this case, we're going to need to solve for an a because we don't have anything. We're having to do the entire thing transformation wise. So f of x is x squared. So g of x, which is our transformation, a x minus h squared plus k. I can find my h and my k just by looking at my picture here. And my vertex is -2, -3. Vertex is hk, and it's -2, -3. All right. So I'm just going to plug these in for my transformation. -2, and then k is -3. Clean this up. All right, it's at this point I need to find my a because there's going to be one. Do not ever use your vertex as your point to find a. I always go to something I can find easily. And it's usually the y-axis unless the y-intercept, unless the y-intercept is your vertex. So in this case, our y-intercept is 0, -1. And I'm going to plug this in for, this is where my x is going to be, and this is going to be my g of x, which is also y. So -1 where g of x is, I'm looking for a, x is going to become 0. -1 is equal to a times 2 squared. Just doing each step, I don't want to lose you. 2 squared is 4. I'm going to move my 3 over. 2 equals 4a, divide both sides by 4, and a equals 1/2. So final answer, g of x equals a, which is 1/2, x plus 2 squared minus 3. And that's it. That's what you have to do to take a graph and solve for the vertex form or standard form of the function. Okay. Next, find the vertex of the quadratic function. Okay, there's a couple different ways we can do this. One is by completing the square. The other way is by HK. H is equal to -b over 2a. You need to know what a is. A is 2 and b is -6. So -6 over 2 times 2 is +6 over 4, which is 3/2. All right, let's take k is equal to f of h. So f of 3/2. Because this is a 1.5, if you'd used a decimal for this, it would have been fine. However, if it would have been a 2/3, I would not wanted you to do decimal, because then you would be rounding and your answer would be approximate and not correct. I want exact answers, okay, not approximate. All right, so let's plug in 3/2 for x. So 2 times 3/2 squared minus 6 times 3/2 plus 7. All right, so we'll just come down here. 2 times 9/4 minus, well, this reduces. 6 divided by 2 is 3. -3 times 3 is 9. All right, this reduces 2, so that's 9/2 minus 2. -9 plus 7 is -2. And then the last part of this, I can just go 9/2 minus 2. Just going to go ahead and make this fractional form real quick. Denominator's 2. So this needs to be 4. So 5/2. That can be 2.5, or you can make it 2 1/2, whatever you want to do regarding that. 2.5, they're all going to give you the same. So your vertex for this, if you put it in decimal form, was 1.5, 2.5. If you put it in fractional form, it was 3/2. And what was the other one? 5/2. Oh, losing my pen. Next page. All right, or you could have 1.1 1/2 and 2.5. It's all the same. So those are my answers for my vertex. It says rewrite the quadratic in standard form, in vertex form. So I'm going to come up here and do that. Standard or vertex form, f of x, a, x minus h squared plus k. I know what my a is. It's the coefficient of the x squared. So it's going to be f of x is 2. X minus 3/2 squared, and then plus 5/2. There is my standard or vertex form of the quadratic. All right, and then we're going to talk about domain and range. So I want to go back. If we're going to do domain and range, let's go back and talk about the ones we've already done. I'm going to pause real quick because I need a sip of coffee. Okay, let's talk about domain and range of everything we've looked at so far. So the domain for any quadratic, and we've discussed this in the last module, is always negative infinity to infinity. That is your x values. Because it keeps going out, 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 all x values are included. So the domain is all real numbers. The range, however, is where things change. The range can either, it's going to have either a max or a min starting point, and your vertex is your key. And it's always, because remember your H is your domain, your K is going to be a part of your range. It's either going to be the first number or the second number, depending upon if it's opening up or if it's opening down. If it's opening up, as this case, remember range, it starts from the lowest point and then it's going up. So our lowest point here is what? -4. So it starts at -4 and then it goes to infinity. Let's look at the next one. It has a min point as well, the lowest point, and it is at 1. So domain is the same, all real numbers, or negative infinity to infinity. And then your range starts at 1 and it's opening up, so it goes to infinity. I don't see any to where, oh, there we go. All right. Let's pretend, because I want to make sure you have it here. Let's pretend like, I'm just going to do a quick drawing of a parabola. We have a parabola that's right here and it's opening down. You know I can't draw, but I want to make sure you understand this. The domain for this is negative infinity to infinity, but the range for this, again, the lowest number is negative infinity. And where's the highest point? The highest point is at 5. So that would be your range for this guy. Okay. Start with the lowest number and go to the highest. Let's do the next one. Domain, negative infinity to infinity. The range is going to start at -1 and it's going to infinity. Okay. The next one, domain, negative infinity to infinity. The range starts at -3 and goes to infinity. We can do this one as well, even though we can't see a picture of it. You could put this in your calculator if you'd like to, but all we need to know is what is it, the justification, what does it kind of look like? Is it opening up? Is it opening down? How do we know? Well, I know it's opening up because the coefficient of x squared is positive. So it has to open up. There's no reflection here. So it's going to be an opening up, which means that my 5/2 is my lowest point. So therefore my range is 5/2 to infinity. Okay. If this was a -2, then my answer would have been negative infinity to 5/2. All right. It all is depending upon whatever that coefficient of x squared is. Perfect example right here. So it says find the domain and range of this. We know it's a quadratic, so therefore the domain is negative infinity to infinity. That's all I need to do for that. My range has to do with what my k is for my vertex. So I need to know, well, first of all, do I know where my k is going to go? Yeah, I already know where my k is going to go because I know that this parabola opens down. This is an opening down parabola. I don't know where it is. So that means my k is going to be my highest point. And my lowest is going to be coming up, so it's negative infinity. I just need to find my k. All right. To do that, let's find our vertex. Our vertex is hk. H is negative b over 2a. Negative b was negative b. 9 is b over 2 times -5. So that's 9/10, and it's positive. That's my h. My k is f of h, which is f of 9/10. Plug in 9/10 everywhere there's an x squared. -5 times 9/10 squared plus 9 times 9/10 minus 1. Do a little algebra. 81 over 100 plus 81 over 10 minus 1. I can reduce this, 5 and 20. So it's negative 81 over 20 plus 81 over 10 minus 1. I can make my denominators all 20 just to make this easy. So negative 81 over 20 plus 2 times 81, which is 162 over 20 minus 20 over 20. Calculator. So negative 81 plus 162 minus 20 is 61. That's all I need. Would that come out? Oh, it's 3.05. That's not horrible. It's not a improper. You could have used 3.05, but I'm going to stick with a fraction. So my vertex is H was 910 and K was 61 over 20. So I can come over here and just say my range is from negative infinity to 61 over 20. Okay. Determining the max and min values of quadratic functions. All right. Well, it's pretty easy to see. The min is the lowest points. The maxes are going to be the highest point that's happening. You're not going to ever use the infinity portion of it. It's all going to have to do with your vertex. So we know that where x is 2, we're going to have a min point at 1. All right. So the minimum value of 1 happens when x is 2. Over here, the maximum value happens when x is negative 3, and that value is 4. We're going to use this to find answers for some word problems as well. Speaking of, all right, I'm going to pause real quick, take a minute to read this, and then we'll go through it. Okay, so we've got a backyard farmer wants to enclose a rectangular space for a new garden within her fenced backyard. She's purchased 80 feet of wire fencing to enclose 3 sides, and she will use a section of the backyard fence as the 4th side. So let's pretend like this is her backyard. Again, you know, I can't draw. This side is against her wire fencing to close 3 sides, and she will use a section of the backyard fence as the 4th side. So let's pretend like she's already got a fencing here, and that will be her back side. So we'll have, she's wanting to enclose a fencing, and this is supposed to be straight. Oh, Lord. All right. So we want to have this to where she's got the garden here, and she's got a length and she's got a width. This length and this length are going to be the same. All right, so there's her 3 sides. All of these have to add up to 80 feet of wire. All right, so L plus W plus L has to equal 80 because that's the max fencing that she got. The max amount of wire. Okay, so, well, what is that? We can solve for W so that we can have a linear function out of this. Let's clean it up a little bit. 2L plus W is equal to 80. I'm going to solve for W by subtracting 2L from both sides. W is just negative 2L plus 80. All right, there is our width. What we know is, okay, find a formula for the area enclosed by the fence if the sides of the fence perpendicular to the existing fence have the length L. All right, cool. And they want us to find the area. Well, the area for a rectangle, the area is just the amount of space that this garden is going to have available. All right, it's not the length around it. We know the length around it's going to be 80 as far as for those 3 sides, but we want to know how much space we're going to get maximized by that 80 feet of fencing. All right, so let's go with length times width. Area is length times width. L is just L, and then width we already know is negative 2L plus 80. All right, we can just multiply those. That's negative 2L squared plus 80L. Now, what we can do to find out, well, find a formula, close. Okay, that would be that's our area. That's our formula. Area based on L, based on the length, is negative 2L squared plus 80L. That's the answer for A. And then B is we need to find out what are the dimensions that she's going to have for her garden. We can do that by just finding the vertex for this. And the vertex, remember, is HK, and H is negative B over 2A. That H is going to tell us what the length is that we're going to use for this. Okay. So, and then the K is going to give us the area that we would maximize this with. So negative B is negative 80 over 2 times negative 2. Negative 80 over negative 4 is 20. So our length, our H, is 20. And our K is A of H, which is A of 20. And so negative 2 times 20 squared plus 80 times 20. 20 squared is 400. 80 times 20 is 1600. This is negative 800 plus 1600. So this is 800. So our vertex is 20 and 800. All right. Well, what does that mean? That means the max area we're going to have, max area is 800, and it's feet. What are we doing by feet? Yeah, feet. So it's square feet. But the area is always measured in squares. So feet squared. And then the length is going to be 20 feet. And that means the width, which is negative 2L plus 80. I'm just substituting the 20 in for L. The width is negative 2 times 20 plus 80. Negative 40 plus 80 is 40. So the width is 40. So for her garden, back up here, her lengths are going to be 20 and her width is going to be 40. And these are all feet. So what dimension should she make her garden? Her dimensions should be 20 by 40. And the most area that she's going to have is 800 square feet for this, right? Let me know what questions y'all have regarding this. All right, another one. I'm going to give you a second to read it, just to think about what's happening. Pause real quick. Okay, finding max revenue. So you're going to learn probably a couple of new things here, maybe just one. Let's talk about it. The unit price for an item affects its supply and demand. That is, if the unit price goes up, the demand for the item will decrease. For example, a local newspaper currently has 84,000 subscribers at a quarterly charge of $30. So that means whenever the newspaper charges $30 for a subscription quarterly, they will have 84,000 subscribers. Market research has suggested that if the owners raise their price to $32 per quarter, then they would lose 5,000 of their subscribers. Well, those are ordered pairs as far as I'm concerned. We just need to do a little calculations for the second ones. Because assuming that subscriptions are linearly related to the price, what price should the newspaper charge for the quarterly subscriptions to maximize their revenue? Okay, well, you need to understand a little bit about revenue in order to do this as well. All right. That being said, let's do our ordered pairs first. When they charge $30, they have 84,000 subscribers. There's our first one. The second one is when they charge $32, they have 5,000 fewer subscribers. So when you take the 84,000 and subtract 5,000, I think that's 79. So we have 79,000 subscribers if they charge $32 per quarter. All right, we can find our constant rate of change since we're saying this is linear. They're saying this is linearly. So we can find our constant rate of change. Just label real quick. So 79,000, 1, 2, 3, minus 84,000, 32 minus 30. $5,000. I don't know why I needed to calculate that. Don't know. It happens. All right, so negative 2,500. What does that mean? And that means they have a decrease in subscribers of 2,500 people, subscriptions per $1 increase in their in the price per quarter, because this is the subscription over the dollars. All right, so that's what that looks like. Let's create a linear function. So if we want to have how do I want to do this? I'm thinking let's just choose letters. We need to have f of x is mx plus b. Our rate of change is negative 2,500. I need to label what my f of x and my b and my x are. My x is going to be my price per dollar. So price. And then this is going to be my subscriptions. Yeah, subscriptions. All right. So if we're going to do that, we need to find our b. And I can do that by using either one of these 2 points and finding my initial value. So I need to go back in and substitute. I'll use x1 and y1 for that. So 84,000 is negative 2,500 times 30 plus b, and solve for b. 84,000 is equal to negative 75,000. 75,000, yeah. Yeah, 75,000. Add 75,000 to both sides. 1, 2, 3. And that is 159,000. So our subscriptions is equal to negative 2,500 x times the price plus 159,000. That means when the price is 0, you'll have 159,000 total subscribers. All right. To find revenue, because that's where our focus is going to be. To find revenue. Revenue is not profit. Okay. They're not the same thing. You use revenue to find profit, but revenue is not profit. Revenue for this newspaper is the number of subscribers times the price that they're charging. So it's basically f of x times x is what they're doing here. I hate that I used x. It probably would have been better if I used like p for price and stuff, but let's just go with it. Let's go with p times f, but I mean x times f of x, because that's what we're dealing with here. All right, so if we have x, I'm not going to change that, times f of x and then I can multiply those. I just distribute. Negative 2,500 x squared plus 159,000 x. And that's my revenue. All right, that's how it would be calculated. That's a quadratic. That's a parabola that opens down. So there is a max value here, not a min. To find that max value, which is what our focus is, how can we max out that revenue? To max it out, we need to know what our vertex is. Remember, our vertex is HK. To find H, negative B over 2A. So negative 159,000, 2, 3, over 2 times negative 2,500. This is going to be a positive, but I'll just go ahead and do this. 1, 2, 3, over negative 5,000 159 divided by 5,000 is 31.8. So our H is 31.8. What is our K? F of H. So F of 31.8. Plugging in 31.8 for my function here. Negative 2,500 times 31.8 squared plus 159,000 times 31.8. 31.8 squared times 2,500, what is that? 10, 11, 24. What is that? Excuse me. Coffee. 1, 2, 3, 1, 2, 3. Okay, good. All right. So I need to multiply these. And I'm going to go ahead and add. And I got 2, 5, 2, 8, 1, 0, 0. All right. That's K. So if they charge $31.80 for a quarterly subscription, they will max out their revenue of $2,528,100. That's what that means. Now, if you write that out for your exam, you're going to want to make sure, because we're in America, you always round to the penny, which is in the hundreds place. So if you were writing this out, if you were interpreting what this means, you would say, if the newspaper charged $31.80, so if the newspaper charges $, correct units, $31.80 for a quarterly subscription, P or B, I never remember this. I'm looking, B, subscription, sure. They will max revenue by $2,528,100. Kind of a cool thing. That's really a cool thing that you can do with this. All right, let's keep going. Find the x and y intercepts of a quadratic function. Well, this one doesn't have any x-intercepts. No, the other word for x-intercept is what? Zeros. So no zeros. All right. The y-intercept is just 0, 5. For this one, there's one x-intercept, and that's at 2, 0. The y-intercept is at 0, 3. So there's 1, 0. That's the other way to think about this. This one has 2 zeros, 2 zeros, and those are 1, 0 and 3, 0. The y-intercept is at 0, 2. Looks pretty close. Yeah, might be a little bit higher than that. All right. Finding the x and y intercepts of a parabola. Okay, well, we need to do the same thing we would do before in solving for x and y intercepts. In my case, though, be careful, because I might not say x-intercept, I might say zeros on the exam. You just need to make sure you understand the terminology. So let's do that. To find the y-intercept, you let x equal 0 and solve for y. Remember, y is also f of x. So f of x, and we're going to take our x's and make them zeros. 0 squared is 0 times 3 is 0, 0, -2. So our y-intercept is -2, 0. To find your x-intercepts, to find zeros, you let y equals 0, or f of x, and solve for x. So 0 is equal to 3x squared plus 5x minus 2. I might be able to factor these, or we could do completing the square, one of the two. Let's see what happens when I factor 3x and x. I'm thinking 2 and 1. Ooh, no, that doesn't work. How about 1 and 2? So that gives me a 1 and that gives me a 6. Positive, negative. That works. Okay, cool. It does. So this is 3x minus 1. Make it a little bit cleaner for us, because I'm just working as I go. X plus 2. So once we get that, we set each of these equal to 0 and solve for x. Add 1 to both sides. I get 3x is equal to 1. Divide both sides by 3. Since 3 is attached to x by multiplication, x is equal to 1/3. So there's one of my zeros. Subtract 2 from both sides. X is equal to -2. And there's my second one. So we've got my y-intercept. And you could write 1/3 0, -2 0 for your zeros. Or you could leave them in the x equals. I'm fine with that as well. Just don't write 1/3 and -2, because otherwise I don't know what you're talking about. All right, given the quadrant, oh no, back here. Find the x-intercepts of the parabola. Okay. I don't think I can factor this one. That's when you let your y equal 0 and you solve for x. So find the x-intercepts or zeros of the quadratic function. I'm going to do this one by completing the square, I think. Or I could do quadratic formula. Let's do that one. We could do that one too. There's so many different things we can do. I don't think I can factor this one into the G parentheses, because that's 2 and 1. And that would either give me, the 4 would either be a 4 and 1 or 2 and 2. That'd be 4 and 2. No, I can't get a 4 in the middle. So let's do x equals -b plus or minus the square root of b squared minus 4ac. All of that's over 2a. You know what my a is, my b is, and my c is. A is 2, b is 4, c is -4. This is going to reduce. These are going to reduce. I could factor out a 2 to begin with and just be done with that part too. I can get rid of that too. Check this out. I want to do that first. I don't know, because most of you, I wouldn't think about it. I like to factor out the 2 to make my life easier. I could factor out a 2 from this and it'd be gone. Just to show you what that looks like. If you factor out a 2, and then you divide both sides by 2, that 2's gone. And then you could use 1, 2, and -2. Because that's the way we have it right now, we're going to have to reduce, which is fine. Let's do that. So -4 plus or minus the square root of 4 squared minus 4 times a times c, and all of that's over 2 times 2. All right, so x equals -4 plus or minus the square root of 16 plus 16 times 2 is 32. All of that's over 4. 16 and 32 is 48. 48 breaks down to what? 16 and 4? No. No. 16 and 3. Yes. Square root of 16 is 4. So this is x equals -4 plus or minus 4 square root of 3 over 4. These are all reducible because you have to be able to reduce all three. Think of it as the V. So x equals -1 plus or minus the square root of 3, and that's it, over 1. All right, so our answers for our zeros are -1 plus square root of 3, or -1 minus the square root of 3. You can write it either way, this way or this way. Or you could put it in ordered pairs. I don't care. It's all the same to me. Let me know what questions you have regarding this. Please do not put this in decimal form, because when you do, the square root of 3 is not pretty. Square root of 3, it's not exact. So because of that, I expect to see it like this. Okay. Last one. Ooh, this one's a good one. Be a good one for the exam. A ball is thrown upwards from the top of a 40-foot high building at a speed of 80 feet per second. The ball's height above the ground can be modeled by the equation, which is a parabola, quadratic. When does the ball reach the maximum height? What is the maximum height of the ball? And when does the ball hit the ground? Well, those are 3 cool things. The first 2 I can answer with just finding the vertex. We know there's going to be a max height because this is an inverted parabola. So it's going to be something like this, where we're going to have a max height somewhere. I'm not saying it's on the y-intercept. It's just to showing you that there's a vertex. It's going to be up here because this is negative. So when we find our h, that's going to be the max height. When we find our k, that's going to be, I'm sorry, the h is going to be when it hits the max height. So this is our when. And this is going to be our max height, the h. And then to find out when the ball hits the ground, that's when our h of t is 0, and we'll have to solve for our zeros on that. So let's start with our vertex. A, h is equal to -b over 2a. A is -16, b is 80. So -80 over 2 times -16. I don't know if that's going to be pretty or not. 80 divided by 32. 2.5. We can go with that. That's lovely. Let's just not deal with the fraction. We don't need to here. So when does the ball reach maximum height? The ball, you have to answer a sentence when there's a question, reaches max height in 2.5 seconds. All right, let's go to B. When does the max height, what is the max height of the ball? Well, that's our K, which is f of h, which is f of 2.5. And we're going to play, sorry, h of 2.5. So that is -16 times 2.5 squared plus 80 times 2.5 plus 40. 2.5 squared is 6.25. 80 times 2.5 is 200. And then plus 40. Now I'm going to finish this out. -16 times 6.25 equals -100. So -100 plus 200 plus 40 is what? It's 140. What is the max height of the ball? The max height of the ball is 140. What are we measuring this in? Feet? Feet. And that happens in 2.5 seconds. The last one is, when does the ball hit the ground? And that is when the height of the ball is 0. So I'm going to take my original function and let this equal 0. Because I'm looking for my x-intercepts, my zeros. And I'm just going to solve. I do not want to fraction this, so I'm going to use the quadratic. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. All right. 6,400 plus 4 times 16 times 40, 2,560 over negative 32 plus 6,400, 8,960. Is that a perfect square root? I have no idea. Nope, it is not. Let's see. Do I want to factor this? I don't think I need to. I almost want to leave that as 94.657. Let's do this. Negative 80 plus 94.657 over negative 32, and then negative 80 minus 94.657 over negative 32. We're looking for time. How fast, when does this hit, when does the ball hit the ground? So I want to put this in my calculator. Negative 80 minus 94.657 divided by negative 32 is 5.458. The other one is, oh, that was this one. The other one is negative 80 plus 94.657 divided by negative 32. And that was this one, and that is x equals negative 0.458. All right. So what is this representing? What is this x value representing? It's representing the time it takes for the ball to hit the ground. Well, time is not negative. We do not have a DeLorean. So we would have to go with this guy. So the ball hits the ground. In 5.458 seconds. I'll tell you what to round to, usually in the directions. All right, that is it for lecture 5.1. Let me know what questions y'all have. Happy to help.